Hello students, welcome to Akshar IIT Foundation. This is Gafar, your physics faculty. Let's start our session. In the last class, we have been discussed about three-dimensional way and two-dimensional way of vector representation, and also we did some questions. Now today we are going to learn about how to add the vectors and how to subtract the vectors. What are the methods we have to add the vectors, what are the theorems we have to add the vectors, and properties of addition of the vectors. This part we'll do today class. Understand? So let's start that part here. So now, so the topic name is what? Addition of the vectors. So better write down everyone. The topic name is addition of the vectors. See, the topic name is addition of vectors. So addition of vector. Addition of vector. Addition of vector is our topic. Understand? Now see here, there are many methods we have to add the vectors. Understand, children? There are many methods. Let's write first the methods, and later we'll go one by one explanation about that methods. Now first method is general method. General method, and second one is triangle law. Triangle law. Triangle law. Next one is polygon law. Polygon law, and most important one is parallelogram law. Parallelogram law of vector addition. Very important. The parallelogram law of vector addition. Even other method also useful, but according to your level, according to JEE mains point of view, according to our calculation +2 level point of view, this parallelogram law is very important. You know one thing, in IPA +1 IPA examination, this parallelogram law of vector addition is for a 4-mark question. But it's so, learn now itself, gain your 4 marks here. Understand? Now one by one we'll go the methods to add the vectors. Now first I will explain general method of addition of the vectors. Okay, so now children, to this general method is a very easy method, and with this general method we can explain this general method with a diagrammatic way. So the diagrammatic way of vector addition, let's see here. Now I am doing now general method here. So general method. So here general method is nothing but, you know, vector. How do you represent the vector in a geometric way? You know, this is a vector A. A bar is a vector. A bar is a vector. And now if this A bar is a vector, you know, this is the tail of the A bar. This is tail of the A bar. This you can take, this is the tail of the A bar. This is head of the A bar. And let me take one more vector. Here this is your one more vector. This vector, you know, B. Now you must add these two vectors. If you add these two vectors, I will show with a equation as A bar plus B bar will give the vector addition. That A bar and B bar become something vector you can treat as a R bar. So R bar is here resultant vector of A bar and B bar when you are adding the two. Now what is this resultant vector? What is this net vector? How much is the value? How to do a vector way. How to represent this r bar a plus b? How to use? How to find? Look at here. Every time to add the vectors as diagrammatic way. So you know this is a tail, this is head, this is tail, this is head. Every time whenever you adding geometric way, first vector head must be attached with the second vector tail. Got my point? First vector head must be attached with the second vector head. You know, the first vector head is this, second vector tail is this. So when you are taking addition of the vectors, you must represent, when you are representing in a geometric way, you must add first vector head, second vector tail. The total length will give addition of the vector, and the direction will give the two vectors direction also in the same direction. Now I will show this. Now this is the first vector here. Okay, this is the first vector. It is not appearing. So this is your first vector, and this is your second vector. So this is A bar and this is B bar. Now from here to here, it will give the, here to here, it will give the total vector, that is nothing but r bar. So r bar you can take from here to here. This is a way we will add the vectors. This is your general method. Understand? This is the general method. Now here the thing is, this general method even you can apply if the vectors acting in different direction. So here one more important point you must know, it is when you are adding this head and tail, you cannot change the direction of the vectors. As it is, you must take whatever is the direction, you must take without changing the direction. So actually this is the vector addition when the vectors acting in the same direction. Understand? When the vector acting in the same direction, look at here. This A vector acting this direction, even B vector also acting this direction. So what is the angle between these two vectors? The angle between two vectors is 0 degrees. So which means that when the vectors acting with 0 degrees, directly how to add the vectors? This is your mathematical way. But how do you show in a geometrical way? This is the way you can represent geometrical way. While representing the geometrical way, what is the condition? What is the thing you must follow? First vector head, second vector tail must be joined. So first vector head, second vector tail, and from tail of first vector, head of the final vector will give you your result. So that is your addition of the vectors. Now this is the part when acting 0 degrees. Let us take one more angle. So let us take if they are acting different angle. Let me take if two vectors acting with a different angle, with acting with theta. Two vectors acting with how much angle? Theta angle. In this situation, how do you take the entire addition? Now see the children, you can take, this is your one vector, you can take this vector as a bar. Understand? Now I'll take one more vector. This is your one more vector B. This is your one more vector B. Now I want vector addition between these two vectors. Vector addition between these two vectors. How do you take vector addition? You know the vector addition mathematically you can represent r bar is equal to a bar plus b bar. This is a mathematical way. But I want a geometric way of vector addition. Geometric way of vector addition. Look at here, when you are taking here, see, now without changing the direction, you must take the addition. Now here I am taking without changing. This is, you know, vector A. This is vector A. I am not changing the direction. And you know, this is a vector B. See, I am not changing the vector A direction, even I am not changing the vector B direction. And what is the condition I have used here? First vector tail, first vector head, second vector tail, I am added. Okay, I am adding first vector, attaching the first vector head, second vector tail. So now, what is the resultant then? Who will represent resultant vector here? Already I said, when you are joining first vector head, second vector tail, the initial vector tail to final vector head, the line represent the what? Your vector addition. This line is nothing but what? This line, you know, this line represent what? Sorry, you can take in a straight line. This line is representing what? R bar. This R bar is equal to what? A bar plus B bar. So in before case also, in previous case also, look at here. From here to here, this vector represents what? Your A bar plus B bar. Now here also, if this is A vector and if this is V vector, first vector tail to second vector head, the line joining represents your final vector, your resultant vector, your addition of the vectors. Understand? I'll give one more example. So here one more example. See the example. Here this is one vector, A bar you can take, and this is another vector, B bar you can take. Now what is the vector addition between A bar and B bar? Now here vector addition between A bar and B bar you can take R bar. R bar is equal to A bar plus B bar. R bar is equal to what? A bar plus B bar. Now when R bar is equal to A bar plus B bar, then how do you show in a diagrammatic way the addition of the vectors? So let us take this A bar is a first vector. Now I am taking here A bar is a first vector, and if this is first vector, this is your head. To that head you must join tail of the second vector without changing the direction. Yes, look at here. This is your first vector. If this is a first vector head, second vector tail, you must be joined. So now I am taking this second vector here without changing the direction. Direction is upward. So this is your B vector. This is your A vector. Now who will show the resultant vector here? The line joining between initial vector tail, final vector head represent your vector addition. Got my point? So now I am taking the line joining. This is your line joining. Now see here, this is your tail of first vector, and this is your head of the second vector. The line joining, this is your line joining. Got my point? This line joining represents your resultant vector, that is R bar. R bar is equal to what? A bar plus B bar. This is your vector addition. It is not normal addition. This is vector addition. It is somewhat different from normal addition. Normally you know 1 plus 1 it is 2. But in vector 1 plus 1 cannot be 2. Understand? 1 plus 1 cannot be 2. Vector addition is different. You must follow vector rules to add the vectors. Because why 1 plus 1 cannot be 2? Because the angle, the direction, the resultant will change. So that 1 plus 1 may not be 2 in vector addition. But according to the normal algebra, if 1 plus 1 is 2 exactly. But here it can't be. It may or may not be 2. Because with respect to angle between the vectors, the value will change. Understand? So now this is the method, is the general method for vector addition. Got my point? So here, look at here. So here when the two vectors acting with 0 degrees. How we have added? Every time addition rule is what? First vector head, second vector tail must be joined, and the resultant would be final to, initial to final you supposed to take. Here also we did the same. Here also we did the same. Here also we did the same. So this is your general method of vector addition. Now we have one more method. What is the one more method? This is general method we done. Now triangle of vector addition. You know the triangle of vector addition is almost equal to the general method only, but I will tell, but it has some statement. With that statement we need to explain. Got it? So now let's go for triangle of vector addition. Triangle law of vector addition. Very, very important. Very, very important. So look at the statement. The statement is very easy. So here, what is in the general method we have used some condition. What is the condition? First vector head, second vector tail you must take, and the resultant would be first vector tail to last vector head. Here also triangular is also same rule, but this triangular is used for when two vectors adding. Only we will use this triangular when two vectors adding. So for example, let us take two vectors. That is just before we did same, like this is one vector A bar. Okay, this is another vector. This is another vector B bar. So this is A vector, this is B vector. Now what is the addition of the two vectors? So now addition of the two vectors, that is, let me take R bar is equal to A bar plus B bar. So in the triangular, any general method, any other method, you will take addition means plus symbol only. But here you are adding in a vector way. Now here I am adding these two vectors. In triangular also, what you will take here? First vector head, second vector tail you must join. So I am taking here first vector, this is A vector, second vector, this is a B vector. So this is a condition. First vector head, second vector tail. This is a condition, as it is condition. The final vector, resultant vector will be, this is your resultant vector. So that is nothing but what? That is nothing but triangle of vector addition. This is, this is like general method only. But why you are kept to a separate name here? Because this triangle law used for only adding the two vectors. It utilized for only adding the two vectors. If many number of vectors present, this triangle is not useful. Understand, children? So that is the reason we kept a separate name. By using the general methods only, we'll try triangular. But what is the thing here? We cannot add more than two vectors with this condition, with this rule. That is the basic information related to what? Triangular of vector addition. Understand, children? So based on this, I'll give one more question. So the one more question is yeah, I'll represent in a one way. So one more example I'll give. See here, I'll take, this is a vector A bar. Every time taking A bar, let us take here P bar. And one more vector, this is what? Q bar. Two vectors we have. Now how to add these two vectors? If you add these two vectors, mathematically you can represent as resultant vector R bar is equal to P bar plus Q bar. Resultant vector R bar is equal to P bar plus Q bar. Now, mathematically it is completed. Now, diagrammatic way. Now this is your first vector. The first vector is P. Now second vector, without changing the direction, I will take this way. This is q bar. Now what is the resultant here? The resultant is first vector tail, second vector head. You must join. So this is forming a triangle. This is forming a triangle. So that we call it as a triangle law of vector addition. But what is the statement? By using this, all the examples, we have to say a statement. We have to give a statement. The statement is, whenever two vectors forming a triangle sides of a triangle sides, whenever two vectors forms a triangle sides, then the resultant would be the closed side will give the resultant. One more time. Whenever two vectors forms a triangle sides, the closed side will give your resultant. That is the statement of triangle law. The closed side must be taken from where to where? First vector tail to last vector head. The closed side must be taken from where to where? First vector tail to last vector head. The line joining or the closed one will give, closed side will give the resultant vector. One more time I am repeating the triangle of vector addition statement. When two vectors forms a triangle sides, the closed side from where to where? From first vector tail to second vector head, the closed side will give you your resultant magnitude wise as well as direction wise. This is your triangle of vector addition, and these are the examples related to triangle of vector addition. I hope you have understood, children. Now I will go for next concept. Next concept. The next concept is just now polygon law of vector addition. Polygon law of vector addition. So you know the name itself, it is telling that polygon law of vector addition. This name itself is telling that if many vectors are present, how do you get the resultant of it? That is your polygon law of vector addition. Just before we did triangle of vector addition, but the triangle of vector addition only used for adding two vectors. But the polygon law of vector addition is used for many vectors. N number of vectors are acting in a single point, or n many number of vectors acting in a plane. Then you can use polygon law of vector. First I will give the example, later I will give the statement, later I will give one more example. Got it? So now write down the heading, polygon of vector addition. Polygon law of vector addition. Polygon law of vector addition. See the children, I will take 4 vectors with different colors. I am giving first example, later I will give the statement, later I will give one more example. Keep it in mind. So this is one vector, A bar you can take, and with one more color I will take, this is one more vector, B bar I will take, and this is one more vector, C bar, and this is your final vector, D bar. This is the way many vectors we are having. Now what is the addition of the vectors? You know, this you can write mathematically as resultant vector R bar is equal to A bar plus B bar plus C bar plus D bar. This is the way you can represent mathematically. But I want this is in diagrammatical way. Now I will do that. So now here, same, you will use the general rule. Compulsory, when you are adding the vectors, you must use general condition. What is the general condition? Every time you must add head of the first vector to tail of the second vector. So I'm using the same thing here. I'm using the same thing, but what is the final result? Look at here carefully. Now this is A vector. A vector head is this, and B vector tail you must take. I will give the same colors here. A vector is red color, so I am writing here without changing the direction. And now you can attach the second vector in the similar manner, but where to where? Head to tail. Now same thing I am doing here. This is a B. Next, finally, C also will apply the same way. This is your C vector. And now finally, the D vector is this. This is a D vector. Now you have joined one by one in a order way. First vector head, tail, head to tail, head to tail. That way you have added. But who will give the final result? Look at here. The final result will be given by the closed path. See, this closed path line from where to where? First vector tail to last vector head will give you a resultant vector of this arc. So that is your polygon law. Understand, children? So when you are joining the all vectors in a ordered way, first vector head to tail, such a manner you are added. But finally, who will give the closed one of the polygon, closed side of the polygon will give your final result. The closed one is nothing but closed one from where to where? Final vector to, not final vector, initial vector to final vector head. The closed line will give what? The final resultant vector of this all A, B, C, D. Now what is the statement here? Okay, we written here examples. What is the statement then? The statement is when you are adding the vectors as a form of head to tail, the closed one of the polygon from initial vector tail to final vector head will give the resultant vector magnitude way and direction way. This is your polygon law of vector addition. I hope you have understood, children. Once again I will tell the statement. Here the statement is, when you are adding the vectors as head to tail, joining the vectors, and the closed path or closed line of the polygon will give closed line of the polygon from first vector tail to last vector head will give you a vector addition, vector of all these vectors. I hope you have understood, children. I'll give one more example. Don't get worried. One more example I'll give here. Now I'll take many vectors. I'm not using colors, or else you'll use colors. Yeah, this is one vector. You can take any direction, not a issue. This is one vector. This is one vector. This is one vector. This is a one vector. How many are there here? 4. You can take even 5 also. So all the way, give the names. This is A bar. This is B bar. This is C bar. This is D bar. This is E bar. How many we have here? 5 vectors we have. Then the 5 vectors addition we require. Addition nothing but mathematically you can say here as resultant vector R bar is equal to A bar plus B bar plus C bar plus D bar plus E bar. You can take small e. Here also it is become small e. Now how to add? This is the mathematical expression, but I want geometrical representation. I'll do now. Look at here. You can take first vector. This is the first vector as it is without changing the direction. First vector A bar. And next, which one you will take? Any one you can take. No, not a issue. What you will take next vector? So this is the first vector done. I'll take this D is a second vector. So D vector. Next one more is what? What is one more? C vector I'll take. Still more, this is a C vector is acting. And next E vector I'll take this way. And finally B vector acting this way. Now the final vector is, final point is, this is your final point and this is your initial point. Now who will show the resultant one? Who will show the resultant one? The closed path, the closed line will give the resultant of polygon. So here closed line is nothing but first vector to last vector. So this is your closed one, this is your R1. So this is the way you can solve the problems. This is the way you can take the vector addition. I hope you have understood, children. So how to take the vector addition? Understand? Got my point? Now, so here we'll do some problems based on this. Open your vector addition, the page number. So polygon law. Yes, here now open page number 35. You can take your material here. Open page number 35 because we don't have sufficient time to explain the parallelogram law of vector addition. So we'll do some problems related to these topics. So now open page number 35 from your material. See the 8th question. Look at the 8th question and even 7th question also you can solve. So 7th question also you can solve, even 8th question also you can solve. First try 8th question here. The 8th question. See the 8th question. Question number 8 from page number 35. That is practice sheet 3. See the question. They given some diagram. See the diagram. The diagram is, in the diagram they given how many vectors? They given how many vectors? 3 vectors. This is the way they given. This is A vector, this is B vector, and this is C vector. And they are asking correct relation. So now see, the correct relation is, so by this relation you can find by using triangle of vector addition, isn't it? This relation you will find a triangle of vector addition. Now first of all you can take 3 vectors separately. So separate vectors separately you can take. This is this is A vector. This is the way it is acting, and this is B vector. This is the way it is acting, and this is your C vector. In 3 different directions they are acting. When 3 different directions if they act, what supposed to do? One by one we will take care. Now this you can treat this is a first vector. This you can take first vector. Yes. This you can take first vector. Yes. Now look at it. This is a first vector. C bar you can take first vector. C bar or else yeah. Now see here, this B bar you can take first vector. Okay, B bar is the first vector. Now I will take, this is A bar actually. If this is a bar, reverse of this A bar is nothing but minus A. Now I will take in a reverse manner. This is A bar, minus A it is big. If this is minus A, then your final vector is your C bar is this, C bar this. Now here, this one and this one you are adding, then you are having C vector. So, B bar minus A bar will give your C bar. And also, this also you can write, this equation also you can write, B bar is equal to A bar plus C bar also you can write. So, I hope which option is showing the same thing. So, that is your answer. So, B bar is equal to what? B bar is equal to A bar plus C bar. So, now, which option is showing that same thing? The third option is showing the same thing. Better take the third option. Okay. So, this is the way we can solve. If the vectors are having this way, first write down separately. Individually you can show without changing the direction. Later, as your wish, you can add. Okay, as your wish, but you must use conditions. I hope you have understood, children. So today I will stop the session. So in the next class we will explain parallelogram law of vector addition. Bye bye.